This video is going to look at when you have holes in the graph of a rational function, and also it's something called oblique asymptotes, which are also called slant asymptotes for reasons that are going to be obvious. So if we start out with holes in the graph, then the graph of a rational function will have a hole in it whenever there is cancellation. And the number of cancellations you make will be how many holes you get. And to find any coordinates, to find the coordinates of a hole, the x coordinate will be the x value that would prevent the cancellation. So that doesn't read very well, so let's just jump right in with an example. So let's look at this first one, j of x. So I'm going to do it up here. So it has x squared minus 36, and then 5x squared plus 30x. So if you're going to see if there's any holes, you need to see where there's cancellation. And to see cancellation, you're going to have to factor it. Now that numerator factors easily. It's x squared minus 6 squared, so it's going to be x minus 6 times x plus 6. And in the denominator, I can see that they have a 5 in common, and that they also have an x in common. So if I factor out a 5x, what I'm going to be left with inside is x and 6. Okay, so now that I've factored that, we can see we do have a cancellation. The x plus 6 is cancel. So I have made one cancellation, and there will be one hole. Now here's very important. In the reduced form, we're left with x minus 6 over 5x, but you must qualify that with x is not allowed to be negative 6. Why is x not allowed to be negative 6? Because if x were equal to negative 6, then you would have 0 over 0, and that's not defined. So you could not have made that cancellation. So you were only able to do that cancellation if x had been negative 6, had not been negative 6. Okay, so make sure that you don't leave that part off. Okay, so here's a little explanation. You can see that the x plus 6 terms cancel, but you can only make that cancellation if x is not equal to negative 6. Otherwise, you would have had 0 over 0, and that doesn't exist. Okay, so this is where we're at now. So to the x coordinate of the hole, and there'll be one hole, will be the x value that would prevent cancellation. So the hole, and we only have one hole because we only did one cancellation, is going to have an x coordinate of negative 6. Now, what is the y coordinate going to be? The y coordinate is going to be what you get when you plug in negative 6 for your x value into the reduced form. Okay, so I'm taking the x coordinate and plugging it into this reduced form. So in the numerator, negative 6 minus 6 is negative 12, and in the denominator, 5 times negative 6 is negative 30. First off, the negative signs cancel. You could put this in your calculator, do the math button, enter, and get it into lowest form, or you could do things the old-fashioned way. I can rewrite 12 as 6 times 2. I can rewrite 30 as 6 times 5. And because it's part of a product, the 6 is canceled, and I'll get positive 2/5. And so that is what my y coordinate is going to be. Okay. So if you're going to see the whole, you have got to get it into completely factored form so you know if there's any cancellations. This was not in factored form, so we had to do a bit of factoring there. Okay. Now let's look at this example 2. It's already in factored form, and that is the easiest kind of question to answer. So let me write it here. We have x minus 5, x plus 1, x plus 3, all over x plus 7 times x plus 1 times x plus 3. Let's just run the full gambit of the last lab. What's the domain? Well, you look at it before any cancellation, and x is not allowed to be -7. X is not allowed to be -1. And x is not allowed to be -3. That would be your domain. And of course, if you were doing that in interval form, from left to right, it's particularly nasty in interval form. That's what the domain would be. But in set notation form, it would be easier to see as that. Okay. Oops. So with domain, you always consider it before any cancellation. If you were asked, what are the vertical asymptotes? What are the x-intercepts? And are there any holes? That is all determined after cancellation. And when it's factored, it's so nice because we have a product in the top, we have a product in the bottom. We see the x plus 1s cancel, and we see the x plus 3s cancel. So I have 2 cancellations, so there will be 2 holes. Now, this question of vertical asymptotes, they're found at zeros of the denominator after cancellation. There would only be one vertical asymptote, and it would be x equals -7, the vertical line with the equation x equals -7. X-intercepts, those are found at the zeros of the numerator after cancellation. And after cancellation, we can see that 5 is a 0 of the numerator of what's left over. So I would only have one x-intercept at 5, 0. So that's from the last lab, but we should know that. Now, any holes, we have 2 holes because we made 2 cancellations. Okay. Now, I could only make these cancellations if x was not equal to -1, because if it is equal to -1, I get 0 over 0 and the thing blows up. And I could only make this cancellation here if x was not equal to -3. So my reduced form, as you can see, is going to be, I'm just left with x minus 5 in the numerator and x plus 7 in the denominator, with the stipulation that I made those cancellations if x was not equal to -1 and not equal to -3. That is my reduced form. So there's going to be 2 holes. The first one is going to have x coordinate -1, and the second one is going to have x coordinate -3. Now, what goes in the y coordinates? Well, this one, I'm going to plug -1 into the reduced form for the y coordinate. So I get -2 in the top, and I get +6 in the bottom. That is not reduced. 2/6 will reduce to 1/3, and that should have been a 5. My bad. Okay, so -1 minus 5 is -6. Okay. And -6 over 6 is -1. Okay. Yeah, I thought that was a -1. It was not. Okay, so I fixed it. And that's the first hole. Okay, now what about the second hole? The second hole has x coordinate -3, and the y coordinate is going to be what you get when you plug -3 into that. So -3 minus 5 over -3 plus 7. So I'm going to get -8 in the numerator, and -3 plus 7 is +4, and -8/4 is -2. So the second hole is found at that point. Okay. All right, so this is all well and fine when you have something that's factored. What are we going to have to do with this one? Okay, well, you're going to have to try and factor it. And notice that we have a cubic. The very first thing you should do is see if it has anything in common in numerator or denominator that you can factor out. And in that denominator, I hope we see that they have an x in common. So that's what my eye was drawn to first. You can factor out an x. And when you factor out an x, you're left with x squared minus 25. And x squared minus 25 is easy to factor. It's x squared minus 5 squared, so it's going to be x minus 5 times x plus 5. So the denominator, I could factor that without too much trouble. The numerator is another matter entirely. We're going to have to use methods from Math 100 to do this. Okay, so if I'm going to factor this, remember if c is a 0, this is from Math 100, then x minus c is a factor. And how do you find zeros? Well, if c is a real number and c is a 0, then the point c comma 0 is an x-intercept. So what I'm going to have to do with this one is I'm going to need to look at the graph of the numerator, which I've done here. And if I'm lucky, I can identify some x-intercepts that are easy, i.e. whole numbers. And here's one, and here's one. And I have an x-intercept at -3, and I have an x-intercept at +5. Now, I also have an x-intercept at here, but it doesn't go through a grid mark nicely, so it's not a whole number. So I can identify those, and so -3 and 5 are zeros. So x minus -3 and x minus 5 will be factors. And if I want to factor this, I can use synthetic division. I can break this down, the numerator. Now, I can use synthetic division with either 5 or -3 in the box. And by the way, if you took my Math 100 course in the first summer session, you are well familiar with synthetic division. If it's been a while since you've done synthetic division, I have a synthetic division review video that you can look at. So just let me, and I've put that in the, okay, let me come here and go to here. Let's come down here. Right here, video review of synthetic division. So if any of you have not had Math 100 for a while and you have forgotten how to do synthetic division, you have to remember how to do it here. This is a video that goes through a couple of examples, okay? All right, so let's get back here. So I want to factor the numerator. Now I'm going to do synthetic division. I can either start with -3 in the box or with 5 in the box. I prefer to start with 5 as a 0 because it's positive. And I'm going to set it up in order to factor this. Of course, it's done down here. 3 times the number in the box, then I'm going to add. 1 times the number in the box, and then I'm going to add. -24 times the number in the box, and then I add, and then that gives me 0, which tells me my remainder is 0, which of course is what we expected. So this is my quotient. And if I start here at the bar, there's my constant, my x term, my x squared term. So I can now write this polynomial as the divisor, x minus the number in the box, times the quotient. So it's going to be 3x squared plus 1x, which I'm just going to write as x, minus 24. Now, I'm nearly there. I just need to break this one down. How do I break this one down? Well, 5 was a 0. And now let's use the other 0, which was negative 3. And let's break this one down. So I'm going to have 3, 1, and negative 24. And then I'm going to put negative 3 in the box. And then I'll be able to break this polynomial down. And then it'll be fully factored. 3 times the number in the box, and then we add. Negative 8 times negative 3 is positive 24, and then we add. So again, my remainder is 0. This is going to be my quotient. And so here's the line. That's my constant. That's my coefficient for x. And so now everything's the same in the denominator. The x minus 5 in the numerator is still coming along for the ride. But now this can be broken down as, well, from this synthetic division, it's going to be x minus the number in the box. So x minus negative 3, which is x plus 3, times the quotient, which is 3x minus 8. And now this is fully factored. So it took synthetic division twice to get it fully factored. So let me scroll down and show you where all this work has already been done. So this is where we ended up. And you can see you can make one cancellation. Because I have a product in the numerator, a product in the denominator, the x minus 5s cancel. So I have made one cancellation. So there is one whole. One whole. And its x coordinate is going to be, well, in order to make this cancellation, x minus 5, x was not allowed to be 5. Because if it had been, I would have gotten 0 over 0, which would have blown the thing up. Okay, so I'm going to get one whole, and the x coordinate is going to be 5. Now, what is the y coordinate going to be? Well, the y coordinate is going to be what I get when I plug 5 into x for this reduced form. So I'm going to have 5 plus 3 times 3 times 5 minus 8, all over 5 times 5 plus 5. So here I'm going to have 5 plus 3 is 8. And I'm going to have 15 minus 8, which is 7, all over 5 times 10. So I'm going to have 56 in the numerator and 50 in the denominator. And of course, if you put 56 over 50, then press the math key and enter, enter. It'll give it to you in lowest form, or you can do it the old-fashioned way. 56 is 2 times 28. 50 is 2 times 25, and so the 2's cancel, and you'll get 28 over 25. Those are the coordinates of the whole. Okay, so I'm now in your web work, you have to understand it's randomly generated. I hope you get one like this where at least the denominator was easy to factor. If you get one where both numerator and denominator look something like that, then you're going to have to use synthetic division on both of them and look at the graph of both of them separately, numerator and denominator, and find x-intercepts that are easy to identify and use synthetic division to break it down so you can do some cancellation. Okay. So this is very much a review of what we did in Math 100. when it came just to polynomials and identifying their zeros and factoring them. So you have a polynomial in the numerator, a polynomial in the denominator. Worst case scenario, you're going to have to do it to both numerator and denominator. Hopefully, I don't have any control over it because it's randomly generated. Hopefully, you'll get one with either a numerator or a denominator like this one that was relatively easy to factor. Okay, so I've only got one like that. Now we come to oblique asymptotes or a slant asymptote. So we've had vertical asymptotes and horizontal asymptotes. Vertical asymptotes are vertical lines. Horizontal asymptotes are horizontal lines. Oblique asymptotes are lines that are not vertical or horizontal, so that's why they're slanted somehow. And that's where it gets that nickname slant asymptote. And so you can see in this picture, the blue is the actual rational function. And of course, that's a vertical asymptote there, so it's not part of the graph, even though it's all drawn in one color. But you can see now that in this case, the graph tends to be approaching a line that is not vertical or horizontal, a slanted line, and this is an oblique asymptote. So that's our picture of what our asymptote looks like. So let's look. Now, when do you have slant asymptotes? You will get a slant asymptote or oblique asymptote. Slant asymptotes happen when the degree of the numerator is one more than the degree of the denominator. You will always have a slant asymptote. So notice you cannot have a slant asymptote and a horizontal asymptote at the same time, because the rules for a horizontal asymptote says if the degree of the numerator is bigger than the degree of the denominator, there's no horizontal asymptote. Okay, so let's look at this example here. Let me Now we see that the degree of the numerator is 2, and we see that the degree of the denominator is 1. And so the degree of the numerator is 1 more than the degree of the denominator. So we will have a slant asymptote or an oblique asymptote. There will not be any horizontal asymptote. All right, so there will be an oblique asymptote or slant asymptote. Now, how do you find it? Well, you do division. So you actually do this division. Now, what you're going to get up here is going to be the quotient. And so the equation of the slant asymptote is going to be the line with the equation y equals the quotient. Now, if you can use synthetic division, then that's great. There are some cases where you can't use synthetic division. So I'm just going to change this slightly just for this. What if this had been that? Then we still would have had the degree of the numerator is 1 more than the degree of the denominator. But we cannot use synthetic division because you can only use synthetic division if the denominator is x plus or minus a number. And you would have had to use long division. So if we're lucky, we can use synthetic division. On the final exam, the one that they've given in the last couple of years has the numerator being of degree 3, the denominator being of degree 2. So that's featured in some of the practice exams. So make sure you know you can remember how to do long division. But this one, thankfully, we don't have to do long division. So I can do synthetic division, and it's x minus the number in the box. So again, you have to remember how to do synthetic division. We're putting 3 in the box, not -3. X minus the number in the box. So 3 goes in the box. And then I need these coefficients. So again, synthetic division is assumed knowledge to be in Math 110. There is a video that I've put there if you need to review synthetic division. Okay, 1 times the number in the box, then we add. 11 times the number in the box, then we add. Now I'm done with my synthetic division. This is the remainder. And these are the coefficients for the quotient. So if I start at the bar, 11 is my constant, and then 1 is my coefficient for x. So the equation of my oblique asymptote is going to be y is equal to the quotient, which in this case is 1 times x, which I'm just going to write as x, plus 11. Okay, so now this is all done in the steps here. All right, so I did that. And the equation of the slant asymptote is y equals the quotient, which gives the line y equals x plus 11. And now what I've done down here is I put this into the graphing calculator, h of x. I've put that equation into the graphing calculator. And so you can see it's what you have there in black. Of course, that's a vertical asymptote, which is not part of the function. And then I told the calculator to graph the line y equals x plus 11. And that's the line you see here that I've outlined in red. And that certainly does fit with it being a slant asymptote. Okay, so that's all that we have for this one. There are 3 questions on your web work. The slant asymptote one should be relatively easy. Okay. The only thing that I need to warn you about is in web work, it gives you the y equal, and then you're meant to fill this in which case you would just write that. Understand that a line is an equation, and if you are asked on the test to type in the equation of your slant asymptote, you must type the full equation. If you type that is not an equation, and that will be counted wrong. Okay, so I wish that web work would make you type in the entire equation, because I think it makes students lazy because it already gives you the y equals. Similarly, if on a test, if you're asked to type in the equation of a vertical asymptote is a vertical line, so this one here looks like it might be x equals 3. And that is the equation of this line here, this vertical line. If you just type that in, that's not an equation. Okay. So just little things like that. And also make sure that you read how the question in WebWorks is worded. Sometimes they'll ask for a vertical asymptote, but they'll only ask you for the x value. So if the equation is x equals 3, then the x value is just 3. But if they want the equation, you got to type in the whole thing. Okay. All right, so that's all. That ends all of the material for test 1. So I'm going to stop there, and you should be able to tackle that web work now.